Disclaimer. Listeners, please be aware that this article is for information purpose and may not in a whole holds the final facts or figures concerning this article upon this subject matter. Everyone is strongly advised to carry out their own research into the subject before making a final decision about this article. We are not responsible for any loss or damage you may suffer as a result of this article. In this article we are going to delve into the study of the Earth and its compositions and features. The Earth is the third planet from the Sun in our solar system and is the only known celestial body to support life. It is a rocky planet with a solid surface and is approximately 4.5 billion years old. The Earth has a diverse ecosystem, consisting of various forms of life, including plants, animals, and humans. The Earth is characterized by its unique features, such as continents, oceans, and an atmosphere. It has a diameter of about 12,742 kilometers, 7,918 miles, and a circumference of roughly 40,075 kilometers, 24,901 miles, at the equator. The Earth's rotation on its axis causes day and night, while its orbit around the Sun takes about 365.25 days, giving rise to the concept of a year. The Earth's atmosphere is composed primarily of nitrogen, 78%, and oxygen, 21%, with trace amounts of other gases. It serves several vital functions, including protecting life by absorbing harmful ultraviolet radiation, regulating climate, and providing oxygen for respiration. Overall, the Earth is a complex and dynamic planet, supporting a wide range of ecosystems and providing a habitable environment for countless species, including humans. The Earth is composed of several layers with distinct characteristics and compositions. The primary layers of the Earth are the crust, mantle, and core. Each layer has its own texture and composition. Here's an overview of these layers. Crust. The Earth's crust is the outermost layer and is relatively thin compared to the other layers. It is composed of two types, the continental crust and the oceanic crust. The continental crust is thicker and less dense than the oceanic crust. It mainly consists of granite rocks. The oceanic crust is thinner and denser, primarily made up of basalt rocks. Mantle. The mantle is the layer beneath the crust and is the thickest layer of the Earth. It is predominantly composed of solid rock, rich in silicate minerals like pyroxenes and olivine. The uppermost part of the mantle is called the asthenosphere, which is partially molten and has a more plastic-like texture, allowing the movement of tectonic plates. Core. The core is the innermost layer of the Earth, located beneath the mantle. It is divided into two parts, the outer core and the inner core. The outer core is composed mainly of liquid iron and nickel. It has a molten state due to high temperatures and pressure. The inner core is solid and consists primarily of iron and some nickel. It is under immense pressure, which keeps it in a solid state despite its extremely high temperature. In addition to these primary layers, there are other terms used to describe variations within the Earth's structure, such as lithosphere, the rigid uppermost part of the mantle and crust, and mesosphere, the lower part of the mantle. These terms are often used in the context of geology and earth sciences. It's important to note that our understanding of the Earth's interior is based on scientific theories and indirect observations, such as seismic waves, mineral properties, and laboratory experiments. The shape of the Earth is approximately an oblate spheroid, which means it is mostly spherical but slightly flattened at the poles and bulging at the equator. This shape is often compared to that of a slightly squashed ball. The Earth's shape is a result of its rotation. Due to the centrifugal force generated by the Earth's rotation, the equatorial region experiences a slight outward push, causing it to bulge outward. This bulging effect is known as equatorial bulge. The Earth's equatorial diameter is larger than its polar diameter, resulting in a shape that is not a perfect sphere. The equatorial diameter is approximately 12,756 kilometers, 7,926 miles, while the polar diameter is around 12,714 kilometers, 7,900 miles. The difference between the equatorial and polar diameters is about 42 kilometers, 26 miles. It's worth noting that the Earth is not a perfectly smooth oblate spheroid due to various factors such as mountains, valleys, and oceanic features, which introduce local irregularities on its surface. However, when considering the overall shape of the Earth on a large scale, the oblate spheroid approximation is commonly used. Yes, the Earth can be affected by earthquakes. An earthquake is a natural event that occurs when there is a sudden release of energy in the Earth's crust, resulting in seismic waves. These seismic waves cause the ground to shake and can lead to significant shaking and vibrations in the surrounding areas. Earthquakes commonly occur along fault lines, which are zones where the Earth's tectonic plates interact and move relative to each other. The movement and collision of these plates can cause stress to build up along the fault lines. When the stress exceeds the strength of the rocks, it is released in the form of an earthquake. The impact of an earthquake can vary depending on several factors, including its magnitude, depth, distance from populated areas, and the local geological conditions. Earthquakes can cause damage to infrastructure, buildings, and other structures, and can also trigger landslides, tsunamis, and other secondary hazards. However, it's important to note that while earthquakes can be destructive, the Earth has natural mechanisms that absorb and dissipate energy, such as the flexibility of the crust and the dispersion of seismic waves. Additionally, measures like earthquake-resistant building designs and early warning systems can help mitigate the impacts of earthquakes and save lives. About the Earth's tectonic plates. The Earth's tectonic plates are large, rigid pieces of the Earth's lithosphere, the outermost layer of the Earth, that fit together like a puzzle. These plates are constantly moving, albeit very slowly, and their interactions give rise to various geological phenomena such as earthquakes, volcanic activity, and the formation of mountains. Here are some key points about tectonic plates. Composition. Tectonic plates are made up of both the Earth's crust and the uppermost portion of the mantle. The crust is relatively thin compared to the mantle and is composed mainly of solid rocks. Types of plates. There are several major tectonic plates, including the Pacific Plate, North American Plate, Eurasian Plate, African Plate, South American Plate, Indo-Australian Plate, and Antarctic Plate. These plates are named after the continents or oceans they encompass.
Plate boundaries. The edges of tectonic plates are known as plate boundaries, and there are three primary types. A. Divergent boundaries. These boundaries occur where plates move away from each other. This movement creates a gap, allowing magma to rise from the mantle, forming new crust. Divergent boundaries often result in the formation of mid-oceanic ridges or rift valleys on land. B. Convergent boundaries. These boundaries form when two plates collide or come together. Depending on the type of crust involved, convergent boundaries can result in different geological features. For example, if an oceanic plate collides with a continental plate, the denser oceanic plate can subduct, sink, beneath the continental plate, forming a subduction zone. This process can lead to the formation of volcanic arcs and mountain ranges, such as the Andes in South America. When two continental plates collide, the crust crumples and uplifts, creating large mountain ranges like the Himalayas. Circa transform boundaries. At transform boundaries, two plates slide horizontally past each other. These boundaries are characterized by faults, such as the San Andreas Fault in California, where the Pacific Plate and the North American Plate slide past each other.
Plate tectonics theory. The theory of plate tectonics explains how these plates move and interact with each other. It suggests that the Earth's lithosphere is divided into several plates that float on the semi-fluid asthenosphere beneath them. The driving force behind plate motion is thought to be the convective currents within the underlying mantle. Plate interactions. The interaction between tectonic plates can result in various geologic phenomena, including earthquakes, volcanic eruptions, the creation of mountain ranges, the formation of ocean basins, and the movement of continents over geological time. The study of tectonic plates and plate tectonics is a significant field of geology and helps us understand the dynamic nature of the Earth's surface and the processes that shape it. Here is a more comprehensive overview of the Earth. Structure and layers. The Earth is divided into several layers: the inner core, outer core, mantle, and crust. The inner core, located at the center, is a solid sphere composed primarily of iron and nickel. The outer core surrounds the inner core and is in a molten state, consisting mainly of liquid iron and nickel. The mantle is the thickest layer and lies between the core and the crust. It is primarily solid rock, but the uppermost portion, called the asthenosphere, is partially molten and allows for tectonic plate movement. The crust is the outermost layer and varies in thickness. It consists of solid rock and is divided into continental crust and oceanic crust. Atmosphere. The Earth has an atmosphere, a layer of gases surrounding the planet. It extends several hundred kilometers above the surface. The atmosphere is primarily composed of nitrogen, about 78%, and oxygen, about 21%, along with traces of other gases like carbon dioxide, water vapor, and noble gases. The atmosphere serves vital functions, including protecting life by absorbing harmful solar radiation, regulating temperature, and providing oxygen for respiration. Hydrosphere. The Earth has a hydrosphere, which includes all forms of water on the planet, including oceans, lakes, rivers, groundwater, and glaciers. The oceans cover about 71% of the Earth's surface and contain about 97% of the planet's water. Water is essential for sustaining life, regulating climate, and shaping the Earth's surface through erosion and deposition processes. Biosphere. The Earth's biosphere encompasses all living organisms and their interactions with the other spheres. It includes a wide variety of ecosystems, ranging from terrestrial habitats like forests and grasslands to aquatic environments such as oceans and freshwater bodies. The biosphere supports a vast array of life forms, including plants, animals, fungi, bacteria, and other microorganisms. Geologic processes. The Earth is dynamic and undergoes various geologic processes that shape its surface. These processes include tectonic plate movement, volcanic activity, erosion, weathering, and sedimentation. Tectonic plate interactions give rise to earthquakes, the formation of mountain ranges, and the creation of ocean basins. Volcanic activity occurs when molten rock, magma, reaches the surface, resulting in eruptions that can release gases, ash, and lava. Climate and weather. The Earth's climate refers to long-term patterns of temperature, precipitation, and atmospheric conditions in a particular region. Weather, on the other hand, refers to the day-to-day variations in temperature, humidity, wind, and other atmospheric conditions. Climate and weather are influenced by factors such as solar radiation, atmospheric circulation, ocean currents, and the distribution of land masses. The Earth is a complex and interconnected system, where the geosphere, atmosphere, hydrosphere, and biosphere interact in intricate ways. Understanding the Earth's processes and systems helps us comprehend the planet's history, diversity of life, and the factors that shape its present and future. In conclusion, the Earth is a remarkable and dynamic planet that harbors a unique combination of geological, atmospheric, and biological systems. Its structure, consisting of layers like the core, mantle, and crust, contributes to its diverse and ever-changing nature. The atmosphere, with its composition of gases, plays a crucial role in protecting life and regulating the planet's climate. The hydrosphere, comprising the vast oceans and other water bodies, sustains life and shapes the Earth's surface through various processes. Interactions between tectonic plates give rise to earthquakes, volcanic activity, and the formation of awe-inspiring mountain ranges. The biosphere, encompassing all living organisms, brings incredible biodiversity and intricate ecological relationships. Climate and weather patterns add further complexity to the Earth's systems. Understanding the Earth's structure, processes, and interconnectedness provides us with valuable insights into our planet's past, present, and future. It reminds us of the beauty, fragility, and importance of our home, motivating us to appreciate and preserve this remarkable planet for generations to come. Thanks for watching.